Hey, Jody here with weldingtipsandtricks.com. Let's do it. Today I'm doing a little TIG welding and some TIG brazing with silicon bronze on thin wall square tubing. It's hot rolled tubing. First thing you got to do is prep it. You're not going to get a good weld or a good braze joint with all that mill scale on there. I like to use a really sharp electrode on thin wall stuff, and I'm using a Jazzy tin ceramic cup with around 22 CFH of argon. First thing I'm going to do is get some really small tacks on here. One reason I want to make really small tacks is because it's always going to pull and draw a little bit. I don't want it to pull too much. So with that much, about a 30-second or so, I don't even have to move it. I know that this other tack is going to pull it right back straight. Sometimes that takes just a few seconds as the tack cools off. And you figure out how much a tack pulls just by trial and error. So once I get it straight that way, I know that if I tack this thing quickly, two small tacks, it's just not going to move. Now, the issue that I usually have with TIG welding, thin wall, square tubing like this is it's just hard not to penetrate all the way through it, especially with that gap and that bare edge there. And when you penetrate all the way through something like this, you pull in oxides from the backside. And I didn't go in and clean the backside, but even if I had, it wouldn't help a whole lot. And puddle gets kind of squirrely like that. So to cure that, I'm just going to leave the rod in the puddle for the rest of it and see what happens there. By leaving the rod in the puddle, it'll cool the puddle off just a little bit, and the hope is that I won't penetrate all the way through so much. And that helped a little bit. That did go a little bit better. But I think it'll get even better if I use a slightly larger filler wire. So I'm going up in one size to a 1/16, again using a lay wire technique, just leaving the wire in the puddle and running over it. Now arc shots are coming pretty soon, but I sped this clip up quite a bit just to make it easier to watch. Right there, that's a problem too. I'm getting undercut because I'm not pushing enough wire in there. And so it's kind of starving the puddle and pulling metal from the backside again. So on thin wall tubing, you really can't afford to have much undercut. I mean, not only is it ugly, but it reduces the thickness and it's going to show up big time if that thing's powder coated or painted. So we got to cure that, and the easiest way I know how to do it is just go another size wire up for this particular joint. 332 ER70S2. I'm just going to lay it right in there, keep a little pressure on it to keep it in the puddle, and we'll see how that goes. That's going much better. Much better. Putting a little pressure on the rod. If it wants to take a little extra rod, I'm doing a little bit of side-to-side motion. This is a perfect scenario here for using pulse at about 1.5 to 2 pulses a second. When we get to the silicon bronze, actually that's what we're going to do, is set it at 2 pulses a second. But right here I just decided to leave it at straight current, leave the wire in the puddle, and just run right over it. All right, let's go just a little bit less heat this time. I'm using the foot pedal, and my max amperage is set on about 65 to 70. I don't think I was quite full pedal on the last one, but I'm going to use just a little bit less heat here and keep a little pressure on the filler wire. Again, don't want it coming out of the puddle. I want it to satisfy the puddle. I don't want to pull oxidation from the backside, and that one's going a little bit better. Now for these joints, these are a little bit easier, but again, it still works great just to use a 332 wire and leave it in the puddle. And by leaving it in the puddle, it cools the puddle a little bit and you don't penetrate all the way through. All you want to do on a fillet weld like this is penetrate down into the root of the joint and not much more than that, especially on thin wall stuff. So leaving the wire in the puddle like this helps to clean the puddle up because you're not penetrating all the way through and drawing all those oxides into the puddle. And for me, it just helps it flow better. So this, I'm going just a little bit cooler on this one too. Again, usually what happens is the very last weld, I finally get something dialed in the way I like it. And that's kind of the way this one is. It's just a little bit smaller weld. I'm keeping it a little bit narrow, a little bit less side-to-side wiggle. And the coverage, because I'm using a little bit less heat, the coverage from that Jazzy tin cup is pretty awesome. And now we're going to do a little TIG brazing with silicon bronze. 2 pulses per second, 33 pulse time, 33 background, and 332 silicon bronze filler metal. I'm not going to worry about getting it straight on this one. It's just an example. So I'm just going to get four quick tacks on the corner. One thing about silicon bronze, though, it does pull a whole lot less. When it cools off and shrinks, it doesn't draw nearly like weld metal does.
Sure.
So for thin wall square tubing like this. It really is kind of a fun rod to use. I know some furniture builders that use this, and some of them blend it off, make a nice smooth fillet. Just depends on what you want. It's not as strong as weld metal, but if you put a lot of metal in there, it's almost as strong, or can be as strong. You put really large fillets and a really large bead like this. 2 pulses a second here. I can leave the rod in the puddle or dip it in and out. 2 pulses a second is not so annoying to look at. I don't like pulsing around anything higher than probably 3 or 4, and anything between there and about 33 is annoying, so I'll do one or the other. Slow pulse or jump all the way up to 33 and higher. Alright, let's try again. The machine displays an average of the pulse background current and the pulse time, and right now it's displaying 65 amps. I'm trying to keep the rod in there often. I don't really want to melt the base metal. You can do it if you're not careful. If you step out too far ahead of the puddle, you want to stay over the puddle, keep the rod in there often, and a cup like this Jazzy 10 really helps for silicon bronze, keeping that puddle clean. The pulse helps a lot too, keeping it cooled off. That'll keep the oxides down a lot too. So now let's do the fillet welds, or I should say the fillet braze joints, because this is TIG brazing here. Silicon bronze melts at quite a bit lower temperature than steel does, about 1900 versus 2800, something like that. So you just want to flow the metal into the root as much as possible, and I'm putting a little larger than normal fillet here because that's what you do with silicon bronze. You need a large fillet just for the strength. Well, let's see if we can do better on the other side. Who put that there? I know who put that there. My son-in-law put that there. He's running the camera today. All right, let's do the other side and we'll wrap this thing up. It really helps to have the metal really clean when you're using silicon bronze, and it helps to have a gas lens with a nice big shield of argon. It helps things go a whole lot better. It helps things just wet in and flow nice, and it keeps the puddle clean. That's what you want with silicon bronze. Hey, I'd like to take a minute and tell you about a new kit that I just added to my store. It's called the Furic Arsenal Kit. It's got all the most popular Furic cups, starting with this number 8 Clear Pro. Works great for steel and stainless steel as well as aluminum. Lights up the way for you, helps you see, especially if you've got older eyes like I do. It really does act like a floodlight bulb almost. You can see I'm looking through the cup there on this aluminum piece. It does a great job on steel and aluminum, and it's a good all-around cup for both. It's also got the Jazzy 10, the ceramic version, which is just a little bit bigger, requires maybe 2 or 3 more CFH, maybe 5 more, but this is a titanium joint here. It's in a fixture that does provide a little chill factor, but titanium will really let you know if you've got good shielding or not, and that's a color-free weld. This little mini tube hurricane project here, you can see it getting in those little tight spots with a long stick out, really got good coverage there. The Furic Ceramic 12 is also really helpful for those situations where you really need good coverage with a long stick out. This new BBW cup design, the clear design, has got a threaded brass insert in it, and for those situations where you just really need perfect argon coverage like on titanium or Inconel exhaust and things like that, this really does fit the bill. You don't always need it, just for those high-end applications where you need really good coverage and possibly a really long stick out. This kit comes in 2 versions. This one was for the 9 and 20 style torch, but I've also got one for air-cooled 17 and 26 style, or the big 18 water-cooled style. Best way to tell what kind of torch you have is just look at the collet body. If it's close to 2 inches long, this is the kit for you. Now the number 8 Clear Pro uses this little setup here with the O-rings, but the rest of the cups use a threaded design. Just moisten the O-rings, slip the number 8 cup on there, you're ready to go. Also included this CK stubby collet body, and that works best with all the rest of them. They just slide on there. That way you don't have to remove O-rings, take them back on, put them back off, or using the different cups. If you'd like to learn more about these kits, just visit weldmonger.com. You'll find them front and center. I appreciate your support. Thanks for watching. We'll see you next time.